If n is an integer and it's between 2 and 7, prove by exhaustion that n squared plus 2 is not divisible by 4. So when it's proof by exhaustion, we literally got to try every one, right? We've got to prove it that way. And we've got to prove in this case that none of them are divisible by 4. Okay, so table is the sort of right way to go about this here. And you notice the integers n, right? So integers are whole numbers, okay? They could be negative, but in this case they're positive, aren't they? From 2 to 7, right? Inclusive of 2 and 7 as well. So 2, 3, 4, 5, 6, 7 there. So what we're going to do then is work out what n squared plus 2 is for each of them, okay? And then we're going to see whether they are divisible by 4, okay? So divisible by 4. And we'll work that out there. So in the first case here, 2, right? So n squared plus 2 becomes 2 squared plus 2, okay? Which is 6, okay? And when you work that out then, is it divisible by 4? Well, divisible means you can divide by it. Well, if I do 6 divided by 4, I get 1.5. So it's not divisible by 4, isn't it? In other words, 4 needs to go into it perfectly. 4 needs to be a factor, so that doesn't work there. Let's try 3 then. 3 squared plus 2, okay, which is 11. And 11 then divided by 4 is 2.75, okay? Not divisible, isn't it? It's not a factor, so that's no good. Try 4 squared. 4 squared plus 2, which is 18, okay? So 18 then divided by 4, which is 4.5, still not divisible, okay? Try 5, well 5 squared plus 2 is 27, 27 divided by 4 is 6.75, again it's not a factor, it doesn't divide it, so try 6, 38, 38 divided by 4 is 9.5, so that's no good, and then finally then 7 will be 51, 51 divided by 4, okay, will be 12.75. So again, we've shown now, okay, none of them are divisible by 4. Do you know what? If we tried 8, okay, it probably would be divisible by 4, okay? So if I did 8, 8 squared is 64, plus 2 is 66. 66 divisible by 4? Actually, it isn't it? 66 divided by 4 is not a whole number, so that would work as well. You know, that would continue our proof by exhaustion. But they only want us to check between 2 and 7. Okay, so we prove by we can say by proof by exhaustion. Okay, n squared plus 2 is not divisible by 4 for n between 7 and 2. Okay, so we've checked them all. That's what it means, proof by exhaustion. You're literally exhausting every possibility, and we've shown that none of them are divisible by 4.